What? The homework is 2.1, 2.2, 2.3. You have a question in 2.1?
Number 2, follow.
Number 2, 1. What did that say?
You have to find the derivative essentially using, well, in part 1, it's the f of x minus f of a over x minus a formula.
Oh, so it says find.
Okay, so it said find using definition 1, which is
Okay,
x
so
minus
it's limit as x approaches a of f of x minus f of
a. And then at the point 1, 0.
at 1 comma 0,
Yeah.
which means your a is 1. And what was the function?
Y equals x minus x cubed.
Minus x cubed.
Yeah.
All right, so let's call this f of x. So f prime of a is equal to what?
X minus a.
X minus x cubed
Minus a plus
minus a minus a cubed over x minus a. And so now it's just a matter of distributing. So here we have x minus a minus a cubed minus x cubed. Right? That scare you?
7, 1,
Well,
3.
this, if I factor out the negative, it's close. Well, I want to use brackets because I do want to suggest something. So it would be x cubed minus a cubed. Does that sort of tell you what you have to do next?
Factor.
Factor this, right? Using what?
x minus a equals
Difference of two cubes formula. Right? And so this is what we limit as x approaches a up. Now x minus a is a common factor. I can factor that out. I'd be left with 1 minus x squared plus ax plus a squared over x minus a. And so as x approaches a, I would get 1 minus a squared plus a squared plus a squared. Right? Which is 1 minus 3a squared. Right? Which, if you notice here, it's like using the power rule, which we learned in 2.3. Right? You can double check your answer here. And now we want a equals 1. So f prime of 1 is just 1 minus 3 times 1 squared. Okay? So difference of two cubes forms is the thing I can remember. Other questions on 2.1? In 2.1? What did God say? S equals 1 over t squared. Equals velocity at t equals a, t equals 1, and t equals 3. A, 1, and 2.
And 3.
There's also t equals 3.
They're all the same thing. So velocity, which they covered in this chapter, was just instantaneous rate of change, which is again, use this formula or the other formula. So velocity would be equal to S prime of A, which is equal to the limit as x approaches A of S of x minus S of A over x minus A. Well, let's use T. So this is 1 over T squared minus 1 over A squared over T minus A. And LCD here is T squared A squared. So you multiply this, you would get A squared minus T squared. Difference of two squares. And so this is minus so I forgot to do this one here. T squared, A squared. Squared is squared, right, for the denominator. Okay, so it's just minus A plus T, because this goes into that negative 1 times, over T squared, A squared. Now, as I let T goes to A, I would get minus 2A over A to the fourth, which is minus 2 over A cubed. And if you thought of this as T to the minus 2 and applied the power rule, you'd realize that you would have gotten that as well. Right, so now that we have T 2.3 knowledge, we could just easily check that we did the right thing. And so velocity at T equals A is this guy. At T equals 1 is, you just plug in 1. At T equals 2, just plug in 2. And you get the idea. And whatever units that was in, distance per unit time. So it's something per second, meters per second, or feet per second.
I don't understand why we use that instead of the other one, the x plus h, or x minus h. Like, I don't understand that. Will you get the same thing if you plug in the other one?
Yeah.
Or
Yeah. They're equivalent formulas.
yeah.
But I use this one because 2.1 emphasized this one.
Alright.
This was definition 1.
I get confused when they actually choose this one like I get it.
Confused about which one?
Like I just like when you have to use this formula instead of the other formula I know they're the same thing but I just get confused with like fx and minus fa over x minus a instead of the other one fx plus minus h minus
X plus h minus x over h.
I just can't comprehend. I don't know.
But you should know these formulas. I derived both of them. You just know how to set up the composite formulas and simplify. Other questions on 2.1 or 2.2? Questions on 2.2? We'll sort of the same thing, 2.2 and 2.1. I don't really know why they are two separate sections. Questions on 2.3? Yes, Ashley? Huh? What's the question? 50 by 0. 50.
Well, the equation is as equal
If
to
a
B.
ball is thrown vertically upward with a velocity of 80 feet per second, then its height after t seconds is s equal.
All right, I have it.
Okay.
He just did. Okay, all right, so we have that S of t is 80t minus 16t squared. A is the max height. Okay, so one interpretation is the following. We'll get other interpretations later on when we talk about increasing and decreasing and maximum and minimums. This occurs when velocity equals 0, right? So the ball is thrown up, it stops in there for a moment and then starts to go down, right? To change direction, it has to stop. That's one way you can think about it. We'll give a separate interpretation to it later, but for now, this is good enough. So the question is, how do we find the velocity? Derivative. B of t is equal to s prime of t, which is equal to 80 minus 32t. Right? So set B of t equals 0. This means 80 minus 32t equals 0. So this implies t is equal to 80 over 32. What is that? 2.5 seconds or whatever, right? So this means that the max height is s of 2.5. Equals whatever that is, right? So remember, height is a position, right? Height is telling you your position. So whenever they ask you about height, you ultimately have to give them an answer that comes from s. But to figure out where you want to evaluate s, you have to figure out when the velocity is 0. Later on, we'll see that maximum and minimums of functions occur precisely when the derivative is 0 or undefined in terms of a sharp corner. But I don't think they told you about that yet. But this will be something that's true in general. Other questions?
Can you read 36?
36. 36? Find the nth derivative of the function by calculating the first few derivatives. Ooh, x to the n. That's not very clear, is it? We've never told you guys what factorial is.
Yeah, that question was pretty confusing. I just found the, you wrote the note in the class, like,
Yeah.
just nx over n minus 1. Just wrote that.
Oh, no, that's not how you want to do it. You want to come with a general form for the nth derivative, but I think here you're going to need to know what factorials are. There's something called n factorial. The notation is the following. N with an exclamation. N! Get excited. Right? It actually means, when n is an integer, it's the product of all integers from 1 up to n. So n factorial is equal to 1 times 2 times 3 until you get up to the number n. Right? So you can just write n factorial. So if y is equal to x to the n, what you're going to do is you're going to start to take derivatives and see what's happening. Right? So if you do the first derivative, nx to the n minus 1, then you're going to do the second derivative, n times n minus 1 times x to the n minus 1, x minus 2, right? And you're going to keep doing this. You'll notice that the third derivative would be n times n minus 1 times n minus 2 times x to the n minus 3. And you'll continue to do this and you'll realize the pattern that's happening, right? So you're going to figure out what is the nth derivative, right? Now if you do it n times, eventually you're going to get 0 here, right? Because it will end up with n minus n, right? After the nth time that you do it. So you're going to end up with x to the 0. And then here you're going to have all numbers from n minus 1 going all the way down to the very last one, right? So this ends up being x to the 0 is 1, and this ends up being n minus 1, 3, 2, 1. So the answer is n factorial. For D, that was part A. Yeah, but you need to know this fact, which you may or may not have seen before. But if you wrote down this as the answer, sure, that would have been accepted, because I'm not sure if you know that notation. If your y was 1 over x, basically I write x as x to the minus 1, and then I start to take derivatives. So y prime would be minus x to the minus 2. Double prime would be positive 2 x to the minus 3. Triple prime would be minus 6 x to the minus 4. Let me write this out differently so you can see the pattern. We minus 2 times 3 x to the minus 4. The fourth derivative would look like minus 2 times 3 times 4 x to the minus 5. So what would the nth derivative look like? Well, notice that when there's a 4 here, you can think of this as multiplying from 1 up to 4, right? So this is actually n factorial. This will always be 1 higher than the 4, right? So when it was 4, it was 3. When it was 3, it was 2. When it was 2, it was 1. So this is x to the minus n plus 1. And then to get the sign change, you can do this. The alternating thing, right? So you realize that when n is odd, you get a negative sign. When n is even, you get a positive sign. So that would be the general formula. To write down nicely, you need to know what n factorial is. So in Calc 3, that is going to be important. You're going to use it all the time. Yeah? Oh, I didn't answer part B.
Professor, so do we have to worry about the n factorial?
No, I wouldn't answer anything to do with n factorial. Forgot part B. When did you tell me before I would do it? What's part B? What's the velocity when it is 96 feet above the ground on its way up? On its way up. Jeez, I can't fit that up here.
Okay, here is A.
Okay, so we know that the position is equal to 96. This means that S is equal to 96. This means that 80t minus 16t squared equals 96, which means that 16t squared minus 80t plus 96 equals 0. This means, what's the common factor here? Huh? 16 goes into 80 how many times? 5. Into what? 5. 65. Yeah, I heard that too. How many times does it go into this? 6 times. So if you factor that, you would have 3 and 2 would be what you get. So you have t equals 2 or t equals 3 seconds, right? obviously in one of these the thing is going up, the other one is going down. Here would be the up, here would be the down. Right? Because it started going up first before it started coming down. So I know the earlier time is the up. So when going up, it asks, what is the velocity? Well, I just plug in v of that time. V of 2 would be 80 minus 32 times 2. Which is what, 60? And on the way down, velocity is 3. 6. Right, so negative velocity implies that it's on its way down, right? Positive implies that it's on its way up.
Wait, I don't get why the time that it's last, it goes up.
The question is you threw the ball up first. Right? The question says it's thrown vertically upwards.
So it takes longer to go down?
No, it goes up before it goes down. The up part of the trip happens before the down part is right? So if one of these is up, it has to be the earlier time. And even
I
if
thought that was like how long it takes. Is that like the...
no, you throw it up. At 2 seconds, it's on its way up. But by the time it gets to 3 seconds, it's
I thought it takes like 2 seconds to go down, 3 seconds to go down.
How do you know it takes 2 seconds or 3 seconds?
you can actually calculate how long the whole thing takes. Alright, pass up the homework.
Anyone else?
This is something you should know, and it's very important, and students make a mistake every time even though you tell them. You can't differentiate a product by just differentiating these and sticking the derivatives together, right? So if you have f of x times a function f of g, it's not the same as just differentiating this one and then differentiating that one, right? It will not work, right? You won't get the right answer, and it's actually not hard to prove. You just pick a random one. Similarly, so know this, not, right? Do not do this. It's a very big mistake, and you will lose tons of points for even thinking about writing that down on the paper. Right? And I can tell from your face that I know what you were thinking just now. And I'll take off points, right? Do not think of do this. So how do we do it? Huh?
Yeah, that is
say my y is equal to a product, right?
Yeah.
How would you find the derivative? Yeah?
F prime of x plus g prime of x. No, f prime of x times g of x plus g prime of x f of x.
Yeah, how do you know that? Well,
That's the product rule. That's how we know that.
that's the rule. You could actually derive it, right? You say the limit as h approaches 0 of this guy minus that guy. Now here's this trick. I'm only going to do this once because and this is something you do a lot in math, which is why I'm showing you one of the derivations. I'm not going to derive the quotient rule, but I'll derive the product rule because it uses a trick that you use all the time in math, so I want to see you using it. Adding 0 in a convenient way so that you can simplify stuff, right? So basically I'm going to add f of x plus h times g of x and subtract the same thing. Right? So I subtract this and add it again, right?
Yeah.
So I'm really adding 0, I'm not changing the value of anything. But what happens is now I can split the fraction into two parts, right? I can split it into this and split it into that. And what you'll notice is in the first fraction,
What did you add?
this, f of x plus h times g of x. I subtracted that and I added the same thing, right? Now what that does, you'll notice that in the first pair, f of x plus h is a common term, right? So I can actually factor that out. And I do that with g of x plus h minus g of x over h, right? Plus, limit distributes across the sum. In this one, g of x is the common term, so I can factor that one out. Now, as h goes to 0, what happens to this? You just get f of x, right? As h goes to 0 of this guy, what do you get?
G prime of x.
G prime, that's the definition of a derivative of g. Plus, now I have g of x. And as the limit as h goes to 0 of this guy is actually f prime. Okay. This is called the product rule. Very, very important rule. Derivative of f times the function g is equal to f prime g plus fg prime. This is called the product rule. And it's used to differentiate products. The quotient rule is derived similarly. You just add and subtract a convenient fraction, then you can factor things out and it looks nicely and you get that. But for now, this is the product rule. So let's do some examples. Examples today. Well, we started out with a simple differentiate x squared in two ways. One, power rule. Two, product rule. So we're going to convince ourselves that this sort of makes sense by doing something that we know what answer it should give us if we apply the product rule. And second example. Maybe I'll do a third example. It's gonna be hard to do. That example would be nice if we already have the chain. I'll save that example for later. So if y equals x squared, what is y prime according to the power rule?
It's 2x.
2x. Okay, so that should be the answer, right? In part 2, if you want to use a product rule, you have to write it as a product. How can you write x squared as a product? Natural. X times x, right? So y equals x squared. Think of this as x times x. Now take a moment to realize that if you actually did the derivative of this times the derivative of that, you would get 1, which we know is not the answer, right? So we know that method doesn't make sense, right? Because we know that this should be the answer, but if you do that, you don't get the answer. Does the product rule give you the right answer?
Yes, it does.
By the product rule, if I think of this guy as the f and that guy as the g, we would get y prime has to be, f prime times g, which in this case is going to be 1 times x plus f times g prime. Now the f was x, and the g prime is 1. That gives you 2x, right? Which is what it should give us, right? So this rule makes sense. The rule of differentiating each thing and sticking it together does not make sense. Do not do that, right? When you have two different functions multiplying together, you can't just differentiate each piece and stick them together. It's just not true, right? You'd have to go through this whole rule. And it's actually pretty easy to generalize. It's like if I had 3 products or 4 products or 5 products, I was going to show you a formula, but I wouldn't be able to show you a nice example until we do like the chain rule, which is the next section. So we'll leave it there for now. How do you differentiate this function?
It's negative 3x squared sin x. We use the part, first we use the power, right? Negative 3x squared sin x. No?
What?
3x tan cos x plus x cubed times sin x.
Wait, sorry, for the last one, I'm confused. What is f, what is g?
F is one of the functions, G is the other one.
So,
It doesn't matter when
x
you
times
take the
derivative of x?
Huh?
So derivative of x times derivative of x?
No. You take derivative of this one, you leave this one alone, plus you take derivative of that one, leave the other one. Right? You take the derivative in turn, right? So first you differentiate the first function, and then you differentiate the second function separately, and add the answer together. Right? You follow that rule. So let's follow it here.
Isn't that negative 3x squared sin x?
No, because you did what I told you not to.
Oh, yeah.
You just differentiate this and differentiate that and stuck it together. Right? The temptation is always going to be there. Do not succumb to it.
So it's negative 3x.
This is f. That is g. So what you're going to do is y prime equals, first you differentiate this and don't do anything with that guy. Right?
But
What's the
wouldn't that be a
derivative?
product rule?
Huh?
Wouldn't that be a product rule?
This is the product rule.
But don't we do power rule first?
Yes, I'd use the power rule to do this. Right? To differentiate x cubed, I use the power rule.
Now you're gonna do.
But I leave the cosine alone. Don't do anything with the cosine.
Now you're gonna do plus.
Then plus.
That is the product rule.
Now I'm going to leave the x cubed alone. And then multiply by the derivative of the cosine. Right?
Oh, only first question. Oh, I thought you were doing that for like both of the questions.
Oh, no.
That's why I was trying to use power rule on that question and like how.
No, if I said power rule, there's no way you can work on a trig function. Power
Yeah,
rule
that's
for
what I was
polynomials.
saying is 3x squared sine x. That's what I was saying. That's the
Yeah,
reason I
this
saying.
was a completely different. I restated a problem.
Yeah.
Yeah, this is done. Yeah, one is power rule, one is product rule. Now I'm moving to this.
Yeah, that's what I think. Like you are forcing me to do that.
Yeah. No, I don't force people to do anything. Dude.
Yeah, you are forcing me to make a mistake.
Right, you can't do a power rule on a trig function. Right? So now, what can we do? Not much here. You can simplify, by factoring out the common term or whatever, which is, in this case, going to be x squared. We're going to be left with 3 cosine x minus x sine x. Huh? Yes, do that. There will be cases where your derivative can be simplified, and factoring is going to be a way that you figure out it can be simplified. So always get into the habit of factoring your answers. Okay.
Do you want to accept the first answer?
Yes, in this case, this is a.
It's a simplified.
Yeah, if I say find y prime and simplify. Okay. Questions on the product rule?
What's that?
You just differentiate one function at a time and add it together. That's basically what it is. You can't just differentiate both and stick the derivatives together. That doesn't work. The next important rule in this section is the quotient rule, and as its name suggests, it's used to differentiate quotients. The rule says if I take the derivative of one function divided by another function, a quotient, what is the derivative? Who knows the quotient?
Prime g minus g prime all over g squared.
Yep. This rule is called the quotient rule, right? Yes.
Is it g squared? Could it be interchangeable with f squared?
No. It has to be g squared.
So the second term,
And the order here also matters. It has to be you take the derivative of the top function first, then minus the derivative of the bottom function. Everything here is exactly as it's supposed to be, right? Order matters. And denominator matters. So if you put f squared, it doesn't make a difference. It makes a difference. So what I like to do is I try to memorize the product rule in the same order, right? So even though the product rule you can write in any order, I write in the same order that I would use the quotient rule. And I just know for the quotient rule I change the middle sign. Right? But it actually, the order actually matters. Right? So I don't know what to tell you to memorize it. People memorize it in different ways. There are a lot of mnemonics like low D, high, minus high. People hear that.
It's catchy. It's catchy.
Yeah. You call the guy at the bottom low and the guy at the bottom top high. Low D high minus high D low over low squared. Of course I know. Over low. If you're, yeah.
Just said YOLO. Oh, I said YOLO.
I'm weird. I I actually say in my head, it's the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom square. Because one time in high school, my professor said that, and I just remember that forever. Like, damn it, now every time I think of quotient, that's what I hear in my head. Wasn't even in math class too, it was in physics class. Okay, so however you want to remember, but make sure you remember like this exactly. The order matters, right? So what are examples that I give you?
What? Oh my god. First things first.
Everything has like first thing. Okay.
Let's have some notes as well. No, just
You made up a stupid thing to memorize that.
What?
You made
Not
up
stuck
a
in your
stupid
head.
thing.
It's a vicious cycle that's being perpetuated through the generations. I bet my professor's professor said that to him, and then he got that stuck in his head. How do you find derivative of this? Sin x over x.
Cos x minus x sin x over x.
Well, you think of this as the f, you think of that as the g. So y prime is equal to, what is it? F prime times g. This is cosine x times x, right? This is your f prime, this is your g. Minus
1 times sin x.
sin x times 1, this is your f, this is your g prime. All over x squared, that's your g squared. So, this is x cosine x minus sin x all over x squared. Can't really simplify that. That would be the derivative of that. What does this mean? How does this function relate to that function? This gives the slope of the tangent line to that function at the point x equals 1, right? So if I graph this function, pick a random point through a tangent line there, the slope will be given by this function.
Always gives the velocity. It always gives the velocity. Right?
If you interpret this as a position function, then it would give you the velocity. Right. Right. Velocity is more of a specific application of this. How about this one? X plus 1 divided by x plus 2. Same thing, right? So f, g. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Right? So this is x plus 2 minus x minus 1 over x plus 2. X minus x, 2 minus 1. Questions? Questions? We're okay?
If you expand that, the derivative is x squared plus 2.
You wouldn't expand.
If you do that wrong,
No, be weird. How would you figure out the derivative of tangent? Realize that you're trying to say sine over cosine. Which means that this is the f, that's the g. So then it's the bottom times the derivative of the top minus the top times the derivative of the bottom. Over the bottom square. Can that be simplified? That's just 1 over cosine squared. Can you write that as a nicer trig function? Nope. Secant squared. Right? So the derivative of tangent is secant, right? What about derivative of secant? Right, it says 1 over cosine.
He's called sine plus tangent x. Tangent squared x, I guess.
So the top, the f is 1, the bottom is g. So when you have the bottom times derivative of the top, what's the derivative of 1? 0. Minus the top times the derivative of the bottom, what is that?
Negative sine x.
All over the bottom squared. This means you would have sine x over cosine x squared. Can I rewrite that?
Yeah.
That's what?
Sin x over cosine x times 1 over cosine x.
Alright, this is the tangents here. I wrote it that way because in the textbook they always write it that way, secant x tangent. Derivative of secant is secant x times tangent x, and we derive that using the quotient. Of course, you can imagine that you can find the derivatives of all the trig functions in this one, because you can write all of them as fractions in terms of sine and cosine, and then using the quotient. What about this one?
Yeah, the same thing.
Huh?
X.
2x times 0.
It's 4x.
It is x. How do you get that?
Oh, the whole answer.
You get 4x minus 0 over 4. You cancel out the 4.
Okay. Is that how you would have done it? Or are you just doing that because we're doing quotient? Huh? You can use the power rule, right? Like right here, I would not use the quotient rule for this. It's just like a trick. Right? This is just 1/2 times x squared. So y prime is just 1/2 times 2x, which is just x. Right? I would not use the quotient rule. You could take you a long time, and I look at you like, that was weird, why did you do that? But it's not necessary.
So it's when the x is on the top and you don't have x on the bottom.
Well, we'll see. What about this one?
Answer.
You can use the power rule. You can use the power rule on the option.
That's exactly.
You can move x to the top by putting x is power negative 1 or 2. 3x negative 1 or 2.
I can rewrite it like that,
Yeah.
and then use the power rule.
Yeah. So negative 3 over 2.
Oh, negative.
Negative 3 over 2 x. Negative 3 over 2. And then you bring it down. Negative
Well,
2x 3 over 2. Or x. You can just put x 3 over 2.
yeah, if you want x3 over 2, it's fine as well.
X 3 over 2.
What about x minus y?
You could have written it as minus 3 over 2 square root of x cubed. Right. So the truth is, calculus and above, we don't care about, oh, it's a negative power, you can't do that. We don't care, right? So back in pre-calc, if you gave this as an answer to something, they'll be like, oh, no, we're going to deduct a point because you wrote a negative power. Calculus, we don't care. If you write this, this, or that, I'm fine with all of them, right?
So you only do the quotient when you have like two variables? Like the same variable in the
No, not necessarily. So you see that here, I wouldn't use the quotient rule, so let's talk about some guidelines. First case is sort of the case where this happens, right? What happened in this case?
Well, it's just a number.
Yeah. Constant denominator, right? Second case, I wouldn't use the quotient rule. Constant in the numerator. This one has a star though. And the star means may need the chain rule, which is the next section. When we get there, we'll do more examples where I can show you that. Basically, if the denominator divides nicely into the numerator, I wouldn't use the quotient. I'll just simplify and divide the denominator into the numerator. So examples of that are things like with polynomials, it's easy. If you have a polynomial on top and then just a single term polynomial on the bottom, odds are you wouldn't do the quotient. So something like y equals Okay? So if I ask you to differentiate, quotient rule or not?
Yes.
No.
No, I would not use the quotient rule. Why? Because that's just x squared plus 2x plus 1 all over x, right? Which I can easily rewrite as x plus 2 plus x to the minus 1. Power rule. It divides nicely into the numerator. There's no reason to go to that, multiply this, minus that, multiply that, divide by this squared, factor out, simplify. You just do that. What about this one?
Yes.
Yes, I would use a quotient rule. Right? Because if you try to divide x into each, you'd have sin x over cosine x plus sin x over x plus cosine x over x, and then that doesn't divide nicely. You end up having to do the quotient rule twice, or bring the x up and do the product rule twice. So this one does just leave it as is and do the quotient rule in the first. What about this one? No, right? For the same reason as before. It seems to divide x into these guys. This is just x to the minus 1 plus 2, x to the minus 3 plus x to the minus 4. Use a power rule. Right? This one? No again? What is this?
2x negative 2. Oh, negative.
Quotient rule?
Yes.
Oh, can you simplify?
No. Difference of two cubes formula, power rule. Right? Note though, a word of caution to this tale is going to be especially important when we get to curve sketching and things like that. The derivative only exists where the function is continuous. Right? So one of the dangers here is that, for example, I didn't give it a nice example. So let me do it. So like if I have this guy, x cubed plus 2x squared over x, I would not use the quotient rule first because x divides into that pretty nicely, right? I would just rewrite this as
X squared.
x squared plus 2x. And then I would say y prime is 2x plus 2. One thing you have to realize here is that this is not defined at x equals 0, right? Which means if someone said, oh, differentiate this, and you did this, and then they ask you, what's y prime of 0? It's undefined, right? Right? So it might look like a polynomial, it might look like, oh, anything I can plug in, but you have to remember the original function was not defined at 0, which means it's discontinuous, which means the derivative cannot exist there. So you have to always keep that in mind. The domain of the original function is very important. There are other times when...
Even if you find the second or the third derivative, you also...
Yeah, so if I do the second derivative again, I would get 2. It's still going to look like the function 2, but there's going to be a hole when x equals 0, right? There will always be a hole there. We'll not be able to get away from it, right? Because the function actually does not exist at x equals 0, right? So while this algebraically makes your life easier, you have to remember that there are situations, it actually restricts you with some of the things you can do, right? So yeah, the derivative of this function does not exist at 0. So you might be tempted to plug in 0 into this, but you can't.
Yeah, circle the first one.
Yeah, so here you will say this for x not equal to 0, right? That's the derivative as long as x is not 0. If x is 0, derivative doesn't exist. Another example. Oh, by the way, let me just write down the Derivative of sine x? Derivative of cosine x? Derivative of tangent x? Alright, we just derived that today. Derivative of cosecant?
Yes, sir.
Wait for you guys to do the quotient rule. It's minus cosecant x cotangent x. Right? Do the quotient rule and you'll see. Right? Derivative of secant, we already did that. That's secant x tangent x. We actually did that today. Cotangent. Minus cosecant squared. Right? You should know this. And by know, I mean wake up out of your bed at 3 a.m. and say, wasn't there a secant? You should be able to tell me within like half a second. Right? That's what I mean, no. You think I won't do it, but don't be surprised if you wake up and see me over here. But what's the reason?
Sleeping in the library. Wake up in the library and see your dad. Comment stuff. Can't do that in my house.
Why are you guys talking so much? Be quiet. Do the problems. This was when to start chain rule, but I don't want to.
Do website for this too tomorrow.
The homework for this and the WebAssign is due tomorrow, yes. So pay attention, be quiet. Differentiate.
You can separate them.
Huh?
Sine x times 1 plus sine x. Times minus.
You want, when you say sine x, bottom times?
1 plus sine x.
No. No. Alright, derivative of 1 is 0. Bottom times derivative of top minus the top times derivative of the bottom all over the bottom squared. What would this be equal to? Sine squared x. You would get plus cosine squared x minus 1. Right?
0. Sine squared x plus cosine x is 0.
That's a special way.
Huh?
Special way.
No?
Sine squared x plus sine squared x equals 1.
Come again?
We have another cosine.
Oh, this is. See, I have to stop listening to you guys. This is actually a cosine, right?
Oh, yeah.
Okay, so what would you have? Just So the only thing you ended up doing was squaring the sine. Okay, so that was good, but I would not have done the quotient rule for this one either. Right? You can split it up into 1 over sine minus cotangent, right? And then just use those formulas. If I saw this, that's what I would have done. I would have written this as y is equal to, well, 1 over sine I know is cosecant minus cotangent. And then just differentiate each. Alternatively. So what about this one? Oh, I know.
Honorary,
Right?
honorary blasphemy number 6.
Right. You do that, syllabus rules. Was that a blasphemy technically?
No.
Technically it's not a blasphemy, but I'd definitely like easier for that problem. Right, you can't split a denominator across a fraction, right? You can only split the numerator. Okay, so here where you're not going to get out of the quotient. So y prime is equal to bottom times the derivative of the top minus the top times the derivative of the bottom. What's the derivative of the bottom?
Oh.
I just said no, right? No. K-N-O-W. Actually, what's the sign? You're supposed to like cosine right away. Over the bottom square. So this would be minus 2 sine x minus sine squared x minus cosine squared x over 2 plus sine x squared. This is just, sine squared plus cosine squared is 1, right? So this is actually minus 1. So this is minus, all right, so that's the derivative. How do I answer the question?
Say equal to 0.
Right? So fraction equals 0 if the top equals 0 while the bottom is not 0 at the same time. So basically here, we don't really have to worry about that. This and that will not be 0 at the same time. In fact, the denominator here is never 0. Because sine can be as low as minus 1 and as high as positive 1. So denominator is okay, so all I need is the top equals 0. For horizontal tangents. I need 2 sine x plus 1 equals 0.
What about the negative?
Yeah, well, if negative this equals 0, so this thing is positive. How do I solve that? Sine x equals minus 1/2. So your x would be equal to what? Is that the only answer? Minus pi over 2? Right, that's not right. What is the answer? Where is sine equal to a half?
30.
We're calculus students, we're thinking radians, not radians.
It's
Pi over 6. Minus pi over 6 is negative. Is that the only solution? Right, it's going to be this, of course, with 2n pi, or what's the other possibility? All students take crap, right? The first negative answer. The first negative answer is in the fourth quadrant. This is where minus pi over 6 is. The second negative answer would be where?
Anywhere.
Over here. So what's the other angle over here?
That's 210.
This would be 6 pi over 6. One more pi over 6, right? 7 pi over 6. Those are your x values. Remember your trick. It's going to be important. It's going to be even more important in calc 2.
Wait, we got the M2 and 2 pi. We got the
It's a circle. Every time you go 2 pi, you end up at the same place.
Oh.
Right? N is any integer. N is any integer.
And with a sign.